Okay, hello everyone. In this video, we are gonna try to solve these two problems about inequalities. So let's just go ahead and solve them. But first, I'm gonna have to apologize in advance if my writing might not seem to be that good, because I'm not used to doing this digital tutor stuff. So let's start. Answer on the first one. Okay. So let's look at the problem here. We have an absolute value of something less than absolute value of something plus 3. Of course, for this kind of problem, we can always do the classically useful method of considering the cases of the value of x, which in this case is the point of interest will be 1/3, because when we set this here into 0, we got x equal to 1/3, and here will be x equal to 0. So there will be 3 cases when the x is less than equal to 0, and the x is in between 0 and 1/3, and x is greater than 1/3. But that's too many, isn't it? So instead of doing that, what I'm gonna do here is noticing here we have an absolute value of something, which is always a non-negative number, right? And in the right side too, we have an absolute value of something added by a positive number. So it's always be a positive number. So I say here, since both sides, my writing, both sides are non-negative, we can just square both sides. So let me name this inequality as 1 by squaring them. Yeah, this is what I mean by my writing might not look that good. Yeah. By squaring them, we got left side will be 1 minus 3x squared, because the absolute value will become when we square it. We don't need the absolute value sign anymore because it's always positive, right? And the right one will be, let me just write it, not everything first. Okay, we go simplify this. It will be 1 squared is 1, 1 times 3 times 2 is 6, 6x, negative 3x squared is 9x squared, less than equal to, here, absolute value of x squared is just x but squared. And the second term is absolute value of x times 3 times 2 will be 6. Absolute value of x plus 3 squared is 9. Simplify them. We have the x squared term. We have 9 here. We have 1 here. So we subtract x squared from both sides. We get 8x squared. And we have only 1x here. One term of x, I mean. And the constant, we have 1 here, we have 9 here, so we subtract 9 from both sides, we get 8, and it leaves 6 absolute value of x on the right side. Okay, we can once again simplify it by dividing both sides by 2. Yeah. Which gives us this expression here. Okay, until this point, we notice that we still have this guy here, an absolute value of x. Also, we, no matter what, we still have to consider the case, but it's still not as hard if we consider the case from this formula, right? Because when we do consider the case this from this step, we will have 3 cases, but since we do it after we simplified, we only have two. That is x when the x is non-negative and when the x is negative. So let me just write it here. First case, when the x is a non-negative, or we write it as x greater than or equal to 0, then absolute value of x here becomes just x, right? A positive x. So the inequality becomes, God, my writing. Okay, becomes 4x squared minus 8x minus 4 less than or equal to 3x. Okay, we can simplify it. We have 3x in the right and negative 8x. So we subtract 3x on both sides. Wait a minute. Something seems wrong. Oh, yeah, this is not 8. That's my miswriting. That's supposed to be 3. Supposed to be 3. I misread my own writing. Okay, we subtract 3 from both sides. That gives us 4x squared minus 6x minus 4 less than or equal to 0. And we can divide both sides by 2. And this quadratic form, we can factorize it. Let me do it quick here. That to be 3. So, okay, so 2x plus 1, 2x plus 1, x minus 2, yeah. This is not factorized one. So here we get the solution. No, wait. Let me write it like this instead. The temporary solution for this here is, well, you can use number line if you want, but because it's just less than or equal to of a quadratic inequality, we can say that the solution must be in between the biggest zeros. The biggest zeros here is the positive 2, and the small zeros is negative a half. But then again, we have to consider the requirement of this case, that is, x must be a non-negative number. So let me draw a number line up here. Okay, the temporary solution is here. Let me, okay, this region here. And the requirement, it must be a non-negative number. So it must meet this condition as well. So let me write in blue. The region that met both both condition is this blue one here. So the solution for this part is, we just write it as this, yeah. Okay, let's continue for the second case. That is when the x is, sorry, x is a negative number. Wait. So let me copy this here to make it faster. Yeah, okay. Let's just switch this part. The second part is, and the second case is, this is negative, and it will change the right side here, because when the x is negative, the absolute value of x will be negative x. So 3 times negative x will give us negative 3x. Okay. So we have negative 3x in both sides here and here, so they cancel each other out. We simplify them, which gives us 4x squared minus 4. And the right hand side is just 0. We can simplify this further. Gives us this. And we can factorize this quadratic form into x plus 1 and times x minus 1. Wait, this should be 0. Okay. Yep. Okay. Just like the previous one, because it's a quadratic inequality about less than, we can just conclude that the temporary solution is the x between the biggest zeros and the smallest zeros. Okay. Next, we consider the condition for x. The x should be a negative number. First, let me draw. The first condition is right here, right? No. Minus 1 to positive 1. And the 0 is an upper circle because the 0 is not included. It's not equal to 0. And it goes over here. So the region where both conditions are met is this, the blue one there. So the solution for this case is, we write it as this bracket, yeah. Okay, so we write the final conclusion here. The final solution will be the union of both solutions we got from both cases. So we write it as x must be inside in this case. Union, the previous case is this, which is none other than equal -1 to close interval. Yeah, we union these two interval will give us -1 to close interval because the 0 is also included there. Yeah, so that's concludes our first problem. Let's go ahead for the second problem. Okay, once again, you can always use the classical usual method of considering the x values. But again, I want to just do it in simple way. So notice that we have squared x in the left side, and in the right side we have a square root of something subtracted by something. To make it in order to us for being able to square both sides, we must make sure that both sides are non-negative, right? So we can just add both sides with 2, which gives, and let me name this inequality 2. Sorry. So we can, by adding it by 2 on both sides, it will, inequality will change into this, yeah. Okay. Whereas both sides are now non-negative, so we can do the same reasoning we did for the first problem here. Let me just copy it. Okay, we can square them. square the left side. Just write it like this. Sorry. I missed the bracket. Mm, two. Okay. Now the left one here, square gives us just x. Square root of x times 2 will give us 4 square root of x. 2 squared is 4. The left side is just x plus 6 because the square root being squared, it just make it cancel out. Yeah. Okay, so we have x in both sides, so they cancel each other out. And we have 4 here. So we can directly divide it by 4. Let's leave it with this expression here. Yeah. Oh, wait, something seems. Oh, we still have 6 here. Sorry, my bad. We divide by 2 then. Okay. Then subtracting both sides with 2 gives us 1 on the right side. And we can divide both sides by 2 again. Maybe I should have divided by 4 since the beginning. Yeah, it doesn't make any difference. Okay. Okay, we got this expression here. Now, notice that this is a square root of x, and this is a positive number. A square root of x is always non-negative. So once again, we can square both sides. Yeah. Let me copy this. Sorry for copying my previous writing, but it's just to make it faster. I square them, the inequality becomes just x greater than equal to 1/4. Yeah, that's it. But it doesn't end there. You must remember that for a square inequality to hold, the requirement, which is the number inside of the square root, must be non-negative. So let me write it here. For this to be well defined, we must have the inside square root must be non-negative. For this expression here to be well defined, both of here must be met. So we can make a number line here. Our temporary solution was this, x greater than equal to 1/4. That goes over here. And the condition requirement we must consider is this, x greater than equal to 0. Greater than equal to 0. What's wrong with my pen? This one here. And x, this one, we simplify this one, we gives us x greater than equal to -6, right? 6 is here. Say this one here. So the region where all the requirements are met is this one here. So yeah, in the end, our answer doesn't change. It's just this. But still, for us to make a conclusion, we still have to consider this two here. Yeah, so don't stop here. Yeah. Okay, that's the solution. Final solution is X. One fourth, one fourth, one fourth, two. Okay, that concludes our two problems here. Okay, that's it. Perhaps. Thank you for watching this video. Person, person, person.